Thank you, and thanks for having me along at this conference. So, I'm probably going to give you a bit of a smorgasbord of insight into different things that are happening in relation to IoT at the University of Edinburgh. If it's okay, I'll run the slide deck like this on this particular screen. Hopefully you can be able to see everything. You'll notice some things changing at the bottom. You might want to, whilst you're getting bored with me talking, have a look at that and see what you can make of that information that's scrolling up at the bottom, and I'll reveal all in a little while. So the research and innovation platform arises from a program of activity that's been going on for probably about 2 years now. Actually, we're getting to this particular point. So a while ago, we were interested in IoT. I was pushing a particular aspect of this within the university itself, and so managed to get people convinced that it might be an interesting thing to do. So we're now at the stage where we're about to launch. We haven't quite launched it yet officially, but it's being used unofficially, our research and innovation platform. So I'll tell you what's involved in that and the types of technology that we're using, one in particular which is called LoRaWAN. But before I do that, I think Jan's in the audience here. I thought I would show off some devices, since that seems to be the thing to do. Everybody talks about IoT. So you might want to have a look at these. I'll spin them around and you can examine them in detail. I start here, maybe. I'll give you some there. There you go. I'll give you some there. So there's obviously a variety of IoT devices, and Jan was pointing out some very cool ones yesterday which are very cheap. These are slightly more expensive, as you can see from the price list up there. What's circulating is actually a LoPi in the clear plastic box, and also some things called estimate beacons, which are Bluetooth based. But what's interesting about a device like the LoPi is that it's basically multi-headed in terms of the communications capabilities it's got on board. So we're all probably fairly used to Wi-Fi and Bluetooth being available on the development board for IoT, but this one actually adds in the LoRa radio. And in fact, the guys at PyCom have now developed something called the PhiPi. It's called the PhiPi because it has 5 communications capabilities built into it as a single device, and it now includes Sigfox and the upcoming MB IoT, which is the mobile operator's version of relatively low bandwidth communications for IoT devices and relatively low energy devices. So if you're interested in core IoT, this is pretty cool. You've got development boards at the top, and then once you're meant to build your product, you can roll them out below, and as you can see, they're relatively small devices as well. The estimate beacons also, which are circulating, which are kind of the rubberized things that you see there, have a large battery inside them. They're purely Bluetooth, but what they do have is a couple of sensors on board, and they also have a couple of GPIO pins, interestingly enough. And so we've been using them to great effect for doing some monitoring in the university. So they're really quite interesting things. They will run on their battery for a couple of years. They'll give you a Bluetooth packet between once every 2 seconds and once every 100 milliseconds. So they're pretty neat. So anyway, that was really for Jan's benefit. And just the last thing was, Jan was showing off a GLI-net router. So here's one as well. This is a Trumpified one. This is clearly better, bigger, possibly the best GLI-net router configuration you can get. These are amazing little devices. This one's a slightly more sophisticated one with the external antennae. That costs about 33 quid. The antennae on these are extra gain antennae, and they cost about 12 quid on Amazon. We use this to do some testing of Wi-Fi, external Wi-Fi, and with this particular device and a laptop and other smaller devices, I was able to get over 200 meters range externally without anything in between, obviously, and it wasn't pouring down with rain at the time either. But there's a lot that you can do with relatively cheap kit. So again, just to kind of reiterate that capability of devices to have multimodal communications. So one of the classic applications in IoT is asset tracking and trying to work out where you are. If you have these kinds of capabilities on a device, and you've got lots of options. So for example, with Bluetooth, you can pick up Bluetooth beacons that might be placed in the environment. So obviously if you get a signal from a Bluetooth beacon, it's a bit like seeing a lighthouse. You know you're somewhere near a lighthouse. Bluetooth has a relatively short range, around about 40 meters or so, although Bluetooth 5 is obviously going to improve on that, but still keep the same energy profile, interestingly enough. Wi-Fi, as I've said, we can demonstrate 200 meters when there's nothing in between you and it's not raining outside, but generally it's relatively short range in the grand scheme of things. But then we've got LoRa. So LoRa is an example of what they call a low power wide area networking technology. It's not the only one. I mentioned Sigfox earlier. Sigfox is a commercial operation. What's great about LoRa is that you can get hold of the standard yourself. You can build your own software implementation if you want. We actually run an open source software stack from an organization called the Things Network, which if anybody's interested in testing out LoRa, you will probably find if you're sitting in operate from some kind of city in the UK or across Europe, or in fact in a lot of other places around the world, you might be lucky enough to be in range of somebody who's stuck a Things Network gateway up in your vicinity. So it's definitely worth having a look at the Things Network. But that's what's quite interesting about this, is this ability to tell where something is. Yes, you can have a GPS on your device, but as we know, GPS doesn't operate indoors. I currently have a GPS logger set up on the window there, and I don't think it's managing to get a satellite fix at the moment. But what's interesting about things like LoRa, whilst you don't necessarily need to have a huge number of gateways because of the distance and range that they're capable of, so for example, it's often quoted that 20 kilometers is kind of an upper bound range for LoRa. It does depend on whether you're line of sight, depends on whether you're in amongst a lot of buildings, that kind of thing. But LoRa operates at sub-gigahertz free part of the radio spectrum. So in Europe, they're currently running LoRa devices on the 868 megahertz ISM band, and in the future they'll run it on the 433 megahertz ISM band. But it's got good building penetration capabilities, and I'll talk about an application that we've used that certainly demonstrates that. And you can even stick your transmitter, your device underground and still get a message off with LoRaWAN that something will pick up. People have been sticking them on satellites now, so they're extremely long range, and there's been some examples of people showing 600 kilometers or more for a LoRa message being transmitted off of a battery powered device with nothing special in terms of antennae and things like that. So it is quite interesting kind of technology. So what do we provide with the Research and Innovation Service? There's kind of two parts to it. One is an infrastructure that allows these kind of low power IoT devices to send messages off over LoRaWAN. So we actually have a network that we have set up across central Edinburgh. And then the second part of that is it's great to get your message off from a device, but what are you going to do with it at the other end? Well, we have some open source, again, software stack to enable you to look at that data. So it's basically Elasticsearch with Kibana on the front end. There's a little bit of Kafka that sits in between the LoRaWAN server and feeding into Elasticsearch, and we also have a Postgres SQL database. So it's all open source based, and if you happen to be a member of Edinburgh University, it's relatively easy for us to set you up and put you on that particular network and get your devices registered. So that's what we're providing, and this is obviously a sort of basic diagram of the infrastructure. It's MQTT that feeds across here, and I think that we had a talk about MQTT yesterday. There's not a great deal to say about that. There are this level of separation between the LoRaWAN server backend and the data analytics. It is an all complete system end-to-end that's implemented on Edinburgh Estate and on Edinburgh University networks. So there's nothing that reaches outside of that at this point in time, and that's for us certainly been an important consideration from a security and governance point of view for being able to set up this type of infrastructure. The great thing is that we can also play around with the networking aspect. And that's a lot of interest internally here at the university from the kind of cyber security point of view. So that's how it's set up, and this is essentially where we have gateways in Edinburgh currently. We have 10. There's a particular type of gateway that we use, which is a relatively, shall we say, more the kind of Rolls-Royce end of LoRaWAN gateways. It happens to be a Curlink V2 gateway, as they call it. The important element in the V2 gateway is, one, is its capacity to handle traffic, because we're interested in testing devices at scale. But it also has a very high resolution clock on board, which means that we can, if a message is received by multiple gateways, then you can do a triangulation calculation and work out where the device has sent you a message from. So that's definitely a positive thing in terms of having a low energy mechanism to determine where a device is out there, because you don't have to have a GPS running on your device. And yes, you can actually find out where things are in buildings as well using this technique. So that's these kind of isochrones here are showing you a kind of 5 kilometer range around them. We do better than that. We can certainly send messages up to 8 kilometers, and we haven't pushed the envelope in terms of what the LoRaWAN specification allows for range tested locally yet. LoRa as a radio communication standard is basically a spread spectrum technique. If you look at Sigfox, that's purely a narrowband radio technique. And what's interesting about that spread spectrum idea is that you can push messages through noise more effectively. You can also push messages over long distance if you take more of the spectrum and you take longer to send your message. Now, because we're currently sitting on the ISM band for this, so we're not paying we're not paying the government billions of pounds to use part of the radio spectrum, it's free. There are rules and regulations about how you use that spectrum. So you have what we call a duty cycle. So this is the amount of time that you can spend transmitting within any particular window. So basically you've got essentially what they call 1% rate, which corresponds to about 36 seconds of transmission per hour for a device. And you have to back off from when having sent a message before you can send again once you've used up your duty cycle. And that's all fine because your devices that you're using with your LoRa radios should all be implemented correctly to ensure that the right thing happens, but you might want to double check that, particularly when you're using new development devices. But I guess the key thing is that still allows you to run applications whereby you can get multi-byte messages off from devices at a reasonable click and not be in violation of that particular duty cycle. So we regularly have devices which can send messages, say, once every 30 seconds. Now, the spreading factor, the standard spreading factors in LoRa run from SF7 up to SF12. SF7 gives you a very short burst of on-air time, but it has a much more limited range, so you may get a message over 2 kilometers. If you run that all the way up to SF12, you may be taking 20 to 30 seconds to send the same length message, but you'll be able to push it much further. So there are some interesting things about adaptive behaviors on devices based on their ability to reach gateways and that kind of thing. But those kind of capabilities within the technology are really interesting. So this is some coverage mapping that we've been doing. So it gives you an indication of people driving around in cars with GPS loggers, like that one in the window, and we're just trying to detect where we pick up those messages from. So that's not a complete picture or an exhaustive picture. And there's a bit of a hot spot over here because this happens to be where our offices are and where we tend to have devices in the office chirping away as we're doing our development and testing things up. But the technology is pretty amazing. Edinburgh is really interesting because topologically it's quite interesting. There's some big rocks. If you just look out the window, there's a really massive one just that way. And obviously we've got the castle as well and that particular part. So it's really interesting looking at how radio messages can make their way around. But the key thing is, as long as you have sufficient gateways, you'll be able to do that coverage. And the amount of infrastructure you have to implement to get a wide area of coverage is relatively small. Compare that to something like 5G, where individual cells are meant to have a range of about 100 meters, so I'm told. I don't know if that's in practice what it'll end up, but they're pretty limited. That's a lot of infrastructure you have to implement to get coverage over a small area. So what have we been doing in terms of testing this stuff out? So we've been doing some occupancy monitoring internally. So we have devices stuffed into cushions. They happen to be this kind of thing, which you can see a force sensitive resistor plugged in actually to an estimate beacon. So it's using the GPIO pins on the estimate beacon. So the estimate beacon broadcasts a standard Bluetooth packet, an advertising packet, and includes information about the state of the pins, the GPIO pins. So we can tell when somebody's actually sat on a cushion. So we've done some occupancy monitoring around that, which is kind of interesting. What we tend to do is use one of the LoPis themselves. We put them in scanning mode. So we use their Bluetooth radio, as you can see here, to pick up information being sent by the estimate beacons. And then we send that back over LoRaWAN, the information that we collect from these. So we have cushions, we have a room set up for that kind of occupancy monitoring lab, as it were, one of the meeting rooms that's used in Argyle House. But we also have a whole bunch of temperature monitoring going on in Argyle House. So the whole of the information systems group essentially moved into this building, which is an old 60s building. And because it's an old 60s building, it doesn't have any modern air conditioning in it. And at certain times, it can get quite uncomfortable. And there's quite a wide variation due to the way that the building is actually laid out with these wings, whether you're sitting on one side or the other side, whether it's the morning where you get super hot or whether it's the afternoon that you get super hot. So we have all of this stuff installed and working away. These LoRaWAN devices run over multiple floors. They're huge concrete floors. It's an old 60s building. But quite happily, those LoRa messages on the SF7 are blurting their way and being picked up by a couple of gateways. So it's quite impressive that the radio technology works like that. Here's some data that we collected on a day, which is kind of interesting. So we have sensors attached to the door. We measure the light level. This is rolled up information from the actual cushion sensors on the individual chairs, so we can see how many people are occupying the room. This is your standard meeting window of time, 9 to 5 in the day. What's also interesting is that we know when the chairs move, because the estimate beacons also have movement sensors in them. And I mentioned that we know that the doors open. So first of all, we discovered that we know when the cleaner enters the room and moves all the chairs around, but obviously doesn't sit down on any of them. So it's quite interesting how much information you can get from very simple sensing. Another aspect of doing IoT at the university is making use of other devices that we already have in place. So we looked at extending this occupancy monitoring to the main library and understanding what was happening in the context of students using that space. So Edinburgh University main library is a core building. It's occupied by thousands of students every day. It actually has over 2,300 individual desk locations, and one of the issues that students have is finding a desk, particularly at peak times. So we've actually been processing data from the cards. So I have a card. This is a card that allows me to go through some gates, entry and exit gates in the main library. So we know by doing a whole bunch of processing on that data how many people are in the main library based on their cards. And we also know, because there are some 230 Wi-Fi access points in that building, it's a multi-tiered building, huge building, currently on which level there's a certain amount of occupancy based on processing that Wi-Fi data. So we haven't added any new devices into that. We did look at it. We also looked at a commercial option which places infrared sensors under the desk, but it's super expensive. To do a building like the main library, you're getting towards the £500,000 mark just for your basic amount of kit that you need to put in. So this is still connected things, whether it's the Internet of Things, I'm not sure, because I'm not really connected to the Internet, thankfully, which is, makes life a bit easier in some sense. So the kind of final project that I wanted to mention a bit more about is the CitySounds project. So you can see down here a box. So this is a box that we put in some trees in the meadow, and inside that box what we actually have is a Raspberry Pi sitting in a little box like that, and a wide spectrum microphone which looks like this. So what's interesting is moving from these kinds of devices, which are, have a certain level of capability. It's not a very fast clock, it doesn't have a lot of memory. It has obviously a huge amount of GPIO pins and that kind of thing. It's basically a bit like an Arduino on steroids. This is actually an ESP32, so one up from your 286. And these are great. You can program these in MicroPython, for example. They're great to experiment with and brilliant, but you can't do a lot of signal processing. So the Pi 0W came out last year. It has a 1 gigahertz processor. You can run Linux on it. You can run a desktop off it. And it has Wi-Fi built into it, and it doesn't even need an external antenna. Neither do these. But what's quite nice is that the way that they do the antenna on that is just a little notch in the circuit board, which is quite impressive technology. These are very cheap, so I hope Jan's impressed that you can get one of these for less than a tenner. And you can create some pretty amazing stuff with that. So that device running Linux on it, I can plug a USB microphone in. Nothing else I have to do. I don't have to install any drivers or anything. And this is a broad spectrum microphone. It samples at 192 kilohertz. And we put all of this together in a box, and we stick a battery with it as well. So these batteries are quite funky. So if anybody's looking for power packs for their IoT devices, this is the one that I've certainly found to be the best. It's called a PowerAdd Pro. It has 30,000 milliamp hours in it, and it's very fast to recharge because it's got a dual recharge input, and it seems to have been pretty stable in use. So we can power a Raspberry Pi with a couple of those, certainly for 8 to 10 days, depending on how much power management we try to put on the Pi, and that's quite good. So I thought I would, given all your backgrounds, just show you what you can do without even having to write any code. I can just do this in shell script, create my IoT device in shell script, which is just fantastic. So I can set up my device, I can create a temporary file system. You'll all know probably, everybody here knows what this is all about. And we can do things like even turning on and off bits of the device as well. So I don't need the HDMI, so I can turn it off, so I can save a few milliamps. I can turn the LED off as well. Saves me a few tiny number of milliamps, but still important. And then we can run a script that accurately will timestamp a file, capture 10 seconds of data, encrypt it as well with PGP. It's all, or GPG, it's all there on the device, nothing else I have to do, and then transfer it securely over to a server over a Wi-Fi network. So we actually have installed a Wi-Fi access point on the edge of the main library, which banks onto the meadows, and that's how all these devices are transferring their data at the moment. So I was quite pleased to be able to do it as simply as that. Didn't have to write any code, it was great. And this is where we currently have 3 of the devices at the moment. So if you happen to get down into the meadows, it's not that far away from here. It's kind of over in that direction. You will be able to see these brown boxes, just like this one. And they're kind of mounted in the trees. They have the microphone in it. I don't know if anyone's going to ask me about listening to people or not, but obviously we take security and privacy incredibly seriously, and actually being able to do a project like this by putting microphones in a public place is a long road of negotiation with various different people, the local community, the council, and explaining to them what mechanisms we use to protect people's privacy. So for example, we have a mechanism that we can apply to the audio data that scrambles people's voice and is completely effective at doing that. Also, the way that we configure these devices, we don't run them completely continuously. They take 10-second samples and they do that in turn across the location. So if you stand underneath one of them, we'll get a maximum of 10 seconds every minute from you in terms of your voice. But the purpose of this project is really about understanding biodiversity in an urban context, and also understanding how people's behavior may influence that. So here's an example recording. So I don't know if anybody can see exactly what that is, but basically we've got 10-second sample, and we've got frequency up the left-hand side. So this is your frequency spectrogram. And the amount of energy of that particular frequency, the more intense it is, the more purple it is on this particular display. So you might be wondering what elements in it. There are essentially 3 elements in this. There's something going on down here. So you might want to look at that and see if you can guess what it is. There's something happening here and here, and there's clearly something repetitive happening there. So hopefully, if this works, you'll be able to hear it. I might have to... Is this microphone really transmitting much extra sound? Let's play this. So, I don't know if this is going to work very well, but we'll try. Everybody's going to have to strain their ears a bit, I think. So hopefully you managed to hear some of that, okay. Obviously there are 3 elements in that. I think you can all understand what there is. We're picking up a siren, so even though we're in the meadows, there's not a road very close by to here, but we can hear aspects of what's going on from that point of view. We heard the birds tweeting, that was here and here. And then we heard something else, and that was actually a builder working on the building, directly on the building. So the key thing is that sonically we can understand what's happening in the environment. And what this project will go on to do is start to apply classifiers to be able to recognize what these types of sounds actually represent. 5 minutes. Okay, thanks. So now we'll play. So what I'll do is I'll show this to you first and try not to look at the top, which of course you will all now do. But now we've got a much broader spectrum view, and there's a lot more stuff that's going on. So I'll play this and you can hear what's in here. So that's just played for us, and we can only hear a certain amount of the spectrum. Actually, most of you in this room, if any of you can hear up to 20k, I'll be impressed. But most of what you will be hearing will be sub 15k, I suspect, with our hearing at our particular respective ages. So there was stuff that you heard, and then there was an awful lot of stuff happening there that you didn't hear. What I'll do is I'll play this. You might have heard a slight click. I don't know if you could hear that from over there. And what we'll do is we'll slow it down, so we'll drop the pitch on the stuff that we couldn't hear. And play it around about there and see if you can hear this. So that was pretty clear, I think. And that was in the middle. It looks a bit like a bomb dropping. And you can hear that high-pitched chirp. So if you haven't guessed already, you can also hear whales in the background. That's not really whales, that was just the birds. Obviously we pitch shifted them, so they sound a bit like whales. It's interesting to hear how much nature sounds similar to itself when you pitch shift it. But what you're hearing is basically a bat. And what you've got at the top is you've got the echolocation as they're hunting for insects. And this other kind of bomb drop is what they call a social call. I suspect it's more like we've got multiple bats, and the bats are shouting at each other, telling them to get out of the way. It's my insect. I think that's really what you call a social call. Okay, so this is pretty cool. This is the kind of stuff that we can pick up with a wide spectrum microphone that otherwise we as individuals can't hear. And that's part of the project, is to capture all of that stuff for the increased view of biodiversity. So I'll move quickly on. You can go onto the OrganiCity website if you want to, and you can go and pick up the data that we're publishing from this particular project. There's a URL at the top, and I'll have it at the end as well. And just so, those bats were actually recorded on LoRaWAN But we've also picked up traces of bats at the meadows as well. We've only been running a short time with the data collection. So again, as I mentioned, this is all feeding into a bigger story around IoT. We have a regional city deal, which is going to be over £1 billion. There's a subcomponent within that the university is heavily involved with, which is an innovation program. We call it a data-driven innovation. It's about teaching people about data ultimately and doing a whole bunch of things to spur new companies and new things taking place. And IoT has a place to play in that. So what you're seeing in the context of this particular project is an example of this type of data being collected and transmitted over high bandwidth communications. We'll then build classifiers. And then using the LoRaWAN technology, amazingly enough, we can create the embedded intelligence in devices out in the field that run on relatively low power, can harvest energy from the environment. But you can actually use that low bandwidth communications network to send updates to firmware and all sorts of things onto those devices, and it's pretty efficient. There's been demonstrations which have shown a 6-minute broadcast transmission from a gateway updating thousands of devices, which are just little tiny battery-powered devices. So capabilities of this type of technology are really interesting. And in terms of that regional city deal, we have an aspiration. So we're here in Edinburgh, but actually we want to replicate what we're doing in Edinburgh across this whole region, which is 7,700 square kilometres. And that includes putting devices and network infrastructure across that whole region to be able to do a wide variety of things, but collecting environmental data set and also taking that through to school education. And there you go. Hopefully, I'm more or less on time. I hope that was interesting. So,
one, maybe two questions. Has any?
Stunned everybody. Yep.
So at the beginning of your talk, you mentioned like the frequency of the microphone. What was it again?
So it samples it up to 192 kilohertz. This particular microphone. So obviously, what that gives you is up to 96 kilohertz in terms of what you've got as recorded sound. But that takes you up into, you'll be able to capture most bat-related activity or aspects of bat-related activity with that. What's really interesting about bats is, and kind of shows up visually on that spectrogram, is just how noisy they are. We don't know that they're that noisy because we can't hear them. If we could hear them, we'd probably be deafened by them, to be honest. The largest bat has a capability of being something like 4 times louder than a jet engine. So, you know, they're quite incredible wee beasties in terms of you know, how loud they can be. When we're picking up bats with these microphones, they can be, because they're higher frequency, the distance that we can capture is obviously much reduced, but we can maybe spot them from up to, say, 40 meters away. Interesting fact.
Just interested, how do you deal with actually buying quantities of pi zeros because they're difficult to get hold of?
So interestingly, people keep telling me they have problems buying pi 0Ws, and I don't know if it's just me, but I've managed to buy exactly the number I've ever asked for. I'm not buying massive quantities, but I am buying more than one at a time, and it's never been a problem.
I've had orders cancelled on people because I've had. So
Then I'm incredibly lucky because you know, I've got about 10 of them now. So.
Chance, are you using a .ac.uk email address for your orders?
Sorry?
Are you using a educational email address for your orders? If you are, that might be why they're doing it, because Ben won't have a...
Interesting. No. Well, there's a few places you can buy them from, like the Pi Hut and Mod My Pi and whatnot, but you can also buy them through Amazon. So I've picked them up through different mechanisms, not because I was trying hard to, but just because I was buying them through different routes at different times. Okay?
Thank you very much.